Welcome to the Physics Focus channel. Today we have to discuss about the space quantization. As we know that the quantization means electrons have a permitted orbits to revolve around the nucleus. That means it orders to a specific orientations in revolving around the nucleus. Okay. Now the quantization have two types. It is the magnitude and the direction of space quantization. Now in this video we have to deal with the space quantization. As we know that when an atom placed in the magnetic field, the electron orbit precesses about the field direction as axis. We know that it's called a Larmor precession. Now we take electron orbital angular momentum vector L traces a cone around magnetic field B such that the theta angle between the L vector and the B vector, okay, which remains a constant. Because in Larmor precession, only the direction of the magnetic angular momentum changes, not the magnitude of the orbital angular momentum. Okay. Now, if the magnetic field B is along z-axis, that is z-axis, okay, in the direction of magnetic field B, or we can say that B is along z-axis. That is same thing. Okay. The component of L vector parallel to the field is Lz, which means Lz along z-axis. Okay. Now, if we resolve L vector into two components, then the Lz is equal to L cos theta. Okay. So we can written here Lz is equal to L cos theta, or cos theta is equal to Lz by L. Now, according to quantum mechanics, L vector has value in the magnitude root L plus 1 h cross. Okay. And Lz has value ml h cross, where L and ml are orbital and magnetic quantum numbers. Now just put the value of L and Lz here. So cos theta is equal to Lz by L, which is equal to ml h cross root L plus 1 h cross. H cross is a cancel term. So cos theta is equal to ml upon L into L plus 1. Okay. So this is our main relation in the space quantization. Okay. Now for a given L, ml can take value 2L plus 1, which means if for L, that is minus L to up to plus L, which is equal to 2L plus 1 values. Okay. So if ml can take a values 2L plus 1 values, so the angle theta also we can be assumed as has 2L plus 1 discrete values. Fine. So if theta can take values 2L plus 1 discrete values, and the theta is the angle between the L vector and the magnetic field vector. Okay. So in other words, we can say that the angular momentum L vector can have 2L plus 1 discrete orientation. With respect to the magnetic field. Because in Larmor precession, only the direction of the angular momentum changes, not the magnitude. Okay. So L can also take a 2L plus 1 discrete orientation. So this is called a quantization. So this quantization of the orientation of atoms in space is known as space quantization. Since the change only occurs in the direction, so it is also called or direction quantization. Now let's take an example to clear the concept of the space quantization. As we know that cos theta is equal to ml upon root L into L plus 1. So now in this example, we have to take L is equal to 1. For L is equal to 1, ml has value minus L to plus n, which means 1, 0 and minus 1. Okay. Now we have to find the theta for the value of ml 1, 0 and minus 1. Now first case, for ml is equal to 1, cos theta is equal to 1 upon root 1 into 1 plus 1. Okay, it is 1 upon root 2. So theta is equal to 45 degree. Similarly, as ml is equal to 0, we have to find theta is equal to 90 degree. And when the ml is equal to minus 1, theta is equal to 135 degree. Okay. So in this figures, for L is equal to 1, it is L is equal to 1, ml has value 1, 0 and minus 1. And there are three different lines are formed. That is, for ml is equal to 1, this line, which makes angle 45 degree. And ml is equal to 0, this line shows that is angle is 0 degree. For ml is equal to minus 1, that is angle is 135 degree. Okay. So for L is equal to 1, there are three different orientation. So we can say that angular momentum vector L can have discrete orientation with respect to the magnetic field. So this is called the quantization, which means discrete value of the orientation. Okay. So the quantization of the orientation of atoms in space is called the space quantization. Okay. So that's all for the space quantization.